Hello everyone. Today I am going to discuss the fourth problem of Leetcode Biweekly contest 125, which is find the maximum sum of node values. So what is the problem? We are given an undirected tree with n nodes, and we are given the ages in ages array, 2D integer array ages. Okay. Now we can perform some operations. We can choose any age u comma v. We are also given a value nums I will be the value of the ith node. So we can do this operation, choose any age u comma v, and perform this operation on u and perform this operation on v. So we are changing nums u to nums u or k, and we are changing nums v to nums v or k. Okay. Now we can perform this operation on any number of edges, any number of times. We have to return maximum possible sum of values after performing these operations. Okay, so let's take one example. Let's take this example only. The graph is like that: 0, 1 and 2, and the values are what? The values are 1, 2 and 1. Okay, the values are 1, 2 and 1. And what is the value of k? K is 3. So our value k equals to 3. So what is the optimal set of operations we can do? So let's check this. So we can choose the s 0 comma 2. Okay, so we are choosing this as 0 comma 2. So what we are doing? We are doing 1 equals to 1 or 3. 1 or 3 is nothing but 2, and we are choosing to changing the value of nums 2 also. 1 or 3 will be 2. So sum of edges is 2 plus 2 plus 2, which is 6. So our answer will be 6. So we are only choosing one edge and changing the value. Similarly, you can check the other examples also, how they are choosing the edges. So we have to choose the edges optimally. Okay, now let's jump into some observations. So the first observation is from constants. What could be our possible constants? So our possible constants is I think n is 2 into 10 to the power 4, k is 10 to the power 9, and other values are not important. So overall time complexity could be order of n or order of n log n, like that. Okay, order of n or order of n log n. Okay, now let's discuss about the solution approach. There is no much observation I have done in the problem, but I have some solution idea and I have tried to implement that. So my solution idea is kind of like this. Let's say we have decided the parity. The one operation, one observation I think that will be helpful to you is that let's say we have done, uh, let's say we have chosen one node, let's say n, or you can say node, and we have done some operation, this operation 10 times on this node, which will be same as doing this operation 0 times on the node itself. Okay, so what I am trying to say is that the parity of the number of operations is important, instead of the total number of operations. So let's say we have done a k number of times, on operation k number of times in some node, then we can take k modulo 2 as the number of operations. So this will help us to optimize the time complexity. Okay, and the second observation, this is the first observation, I can say. The second observation here is that so the total number of operations in the tree will be even, because when we are doing one operation on any edge, we are changing the parity of two nodes. So overall parity after doing all the operations will be 0. These are the two observations we can say. So what I have tried to do is that I have tried to set one parity of each node. So we are, let's say, doing DFS. So we are trying to do DFS on any node, let's say node, and what is the parity of the current node. Okay, what is the parity of the current node after we have done performing the operations on the subtree. So let's say this is our subtree, this is our tree 1 2 3 4. So what I am trying to say is that, let's say the parity of this node is 0. That means after performing the traversal on this tree, the total number of operations on this node 2 is even. Now let's say the parity is odd, or you can say 1, then the total number of operations in this node is odd after performing the operation on the after performing DFS on the subtree. Okay, so that's the DFS node comma p identifies that after visiting or after DFS, the depth first search of the subtree, what is the value of what is the maximum value this node can get with the current parity. Or instead of writing DFS, let me write it as DP, or because we have to find some transition, so dp node comma parity will be our state of the recursion. dp node comma parity will determine what is the maximum value of the subtree starting from node or subtree of the node I, or you can say node I, with uh, the starting node parity of the ith node is our the current parity. Okay, so this is the maximum value. Okay, so let's say we are at some node I and we are trying to check some node j. Okay, now the parity of the this jth node could be either 0 and 1. Now if we have performed some operation on this edge, then the parity of this jth node will change, because we are only dp node parity will only give us the parity in the subtree. So when we are performing some operation on this node, the parity of this node will change. So I will discuss this part in my code. Now what I have to we have to check is that when we are let's say I have some nodes j k l like that. Now if the parity of this this node is 1, then we have to perform this operation exactly on odd number of edges. Okay, so we can perform this operation in one edge, or we can perform this operation in 3 edge. Okay, or if there are n edges, so we can perform 1 3 5 7 like that in odd number of edges. Okay, and if the parity is 0, we have to perform them in even number of edges, 0 2 4 like that. So I will jump into the recursion part now. So recursion part is quite simple. We are doing recursion of some node and the parity value, and we are for every node in the adjacency list of this node, we'll do recursion of the child, let's say ch comma 0, and we will do both recursion of child comma 1. So uh, then this parity does not affect this the traversal. Okay, so let me jump into the code now. I think you will understand it better. So this is our dfs. The parameters are nothing but I and parity. This part is quite trivial, because we have to check that what is the parent node of this. So I always take this thing, parent in my dfs. This helps me. Instead you can take also visited array. Okay, now this part is for the normal dfs. If dpi parity is not equals to -1, this is the memorization part. So we have already visited this state of the recursion we are returning. Okay, and this part is the similar dfs we are doing for parity 0 and 1 for every child node of the current node. Okay, now this part is interesting. This part is modifying the dp array. Okay, so what is this? Okay, we are traversing over every child node. Okay, now let's say we are performing the operation on the edge. Okay, so we are performing this operation on the edge. Now p0 means that the parity of the child node is 0. Okay, now if the parity of the child node is 0 and we are performing the operation, the parity of the child node is 0, that means we have added nums j in the dpj array. Okay, dpj0. So parity of j is 0 means that dpj0 will contain the value nums j. Okay, and dpj1 means that the node this dpj1 will contain ks or nums j. Okay, ks or nums j. Okay, so that's why when we are performing on this operation on the edge, the value of this will get reversed. Okay, value of this will get reversed, so we have to subtract nums j from it, because we have already added nums j. So we have to subtract this thing, and we have to add ks or nums j in case the parity of the child node is 0. Similarly, when parity of the child node is 1, we have to subtract nums j or k, and we have to add nums j. Okay, now p is the maximum of p0 comma p1. Okay, p0 means that the we have performed the operation and the parity of the child node is 0, and p1 means that we have performed the operation but the parity of the child node is 1, and the p value will be the maximum of this thing. Now if we don't perform on this edge, q0 will determine that the parity of the child node is 0 and we have not performed the operation. Okay, we have not performed the operation, so we don't have to subtract anything. Okay, and q1 means that we have not performed the operation, and the parity of the child node is 1, and q is similarly maximum of q0 comma q1. So p determines that what is the value if we don't if we perform the operation on the current edge, and q will determine the maximum value if we perform the operation on the current edge. Now total value will determine the maximum the dpi parity value uh, uh, if we choose the edges or the performing on the edges optimally. Okay, now if what is the reverse thing doing, I will explain it later. Now if p less than equals to q, we are taking reverse as reverse of p minus q. Okay, I will understand it later. Now if the p is greater than q, that means that we are performing on this edge, so we'll check our current parity is or equals to 1. That means our current parity is changing. Now if the current parity is not equals to the parity, so let's say we have performed on even number of edges, but my parity is odd, but my parity of the node is odd, then what we have to do, we have to perform in any such edges. Okay, so let's say these are 3 edges, and I have not performed any such operation. That means that I have to perform on at least one of the edge. Okay, okay, that's where the reverse thing will come up. Or you can take another example, let's say 1 2 3 4, and we have to perform on even number of edges, but we have performed only on one edge. Okay, in that case we have to perform in any other of the edge, or you can reverse this operation. That's why when we are performing on some edge, we are taking p minus q. P minus q means that let's say we have added total plus equals to p, total plus equals to p. Now we have to reverse this thing. Then what we have to do, we have to add q minus p to the total. Then this p will get deleted and q will get added. So we have to take maximum of all these q minus p values. Okay, so if current parity is not equals to parity, we are adding total plus equals to reverse. Okay, now after our perform all the operations are done, we have done with the child nodes or subtree values. Now if the parity of the current node is odd, we are adding num size or k. This part is quite simple. And if the parity is even, we are adding num size. Okay, and this part is just initialization. We are building the adjacency list from edges, and we are doing dfs 0 comma 0. 0 is our root node we are considering, and we are doing dfs 0 comma 1 also. And at the end we are printing our maximum of returning our maximum 0 0, dp 0 0 and dp 0 1. I think you will understand my explanation. I will provide the link of the code also in the description box. This problem is quite interesting. This involves dp tree, etc, etc. I think if you have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thank you.